Hi guys, how's everyone doing? Hope everyone is safe at home. I'm safe too. So let's continue our learning session with something new today that's on motion. When we talk of the word motion, what is the first thing that comes to your mind? Yeah, that's right. It's moving from one place to another. So, motion exactly defined as moving from one place to another. Let's see what is the physics definition of motion. It is a change in the position of an object with time. That is, when an object or anything moves from one place to another, it is called motion. It depends on two things, that is, on distance and on displacement. Before we go into the depth of what distance and what displacement is, let's see some examples of motion. When you throw a book, maybe from a table, when it falls down, that is motion. That is, it is falling from one place to another. When you turn on the tap, water starts gushing down. Flowing water is also an example of motion. Now, let's learn what are the terms displacement and distance. For example, let's take an example to understand this. There are two objects, A and B. The distance between both of them is 10 meters. So now, when we have to calculate the total distance, it is from A to B, but it is told that object moves from A to B and then it comes back to A. So the total distance will be A to B, which is 10, plus B to A, which is again 10. So it comes up to 20. Displacement is the distance from your initial position to your final position. Now, if we move from A to B, the displacement is 10 meters. But if you're coming back to the same point A from where you started, displacement is going to be 0. There are different types of motion. One is rotatory motion, one is oscillatory motion, and one is linear motion. The different types of motion are rotatory motion, oscillatory motion, and linear motion. Now let's see what each of these mean. Rotatory motion. Rotatory motion is when an object rotates in a circular motion. You can say about its own axis. Like for example, Earth rotates around its own axis around the sun. That is an example of a rotatory motion. Let's see what the other two are. Linear motion. When an object, it moves in a straight line. For example, if you have a car which is moving in a straight line along the road, that is an example of linear motion. There are different types of linear motion. One is rectilinear motion and one is curvilinear motion. Let's see what these are. Rectilinear motion is when an object moves in a straight line. For example, like you see this girl playing on the slide, she is going to fall down in a straight line. That is an example of rectilinear motion. Whereas curvilinear motion is where the object moves in a curved path. For example, a snake, it doesn't move in a straight line, it moves in a curved path. That is known as curvilinear motion. Oscillatory motion, on the other hand, is moving through and fro. For example, you move from one position, you go to the other position, and then you come back. Like you have seen the experiment of simple pendulum. It moves about the mean position, that is the center position. For example, a swing, you push it, it moves in front, and then it comes back. Those are examples of oscillatory motion. Now let's learn few terms which are associated with motion. First is speed. Speed is defined as distance traveled by an object per unit time. That is, the distance that you travel by the time taken is defined as speed. The unit for speed is meters per second, and speed is considered as a scalar quantity. Now, what is a scalar quantity? Scalar quantity is what has magnitude but no direction. For example, speed. Now, when you say that you are moving at a speed of 30 meters per hour or maybe 30 meters per second, we do not know whether you are moving in the forward direction or you are moving in the backward direction. Hence, speed is a scalar quantity. Whereas, if you have Google Maps, while navigating through places and it says turn south 30 meters. That is when it is telling you direction as well. So that is considered as a vector quantity. Let's see the other terms. Here in this example, you see the red car. It is moving at a speed of 30 meters per second, and this gray car is moving at a speed of 40 meters per second. So when you are asked what is the speed of the red car, it is 30 meters per second, and the speed of the gray car, 40 meters per second. What is average speed? Average speed is the ratio of total distance traveled to total time taken. For example, if you have three cars moving together and you are given with the time taken by all of them, the sum of the total distance by the sum of the total time is average speed. Next term, which is an interesting term, is velocity. Velocity it specifies both direction of an object and speed. Like we mentioned earlier, it is a vector quantity. That is, it gives you the direction in which the object is moving. Average velocity. Average velocity is the ratio of the total displacement to total time taken. Now remember, displacement, as we studied earlier, is the distance which the object travels from its initial position to its final position. So you have the formula for average velocity as initial velocity plus final velocity by 2. Acceleration. Acceleration is, you can say, an upgraded version of velocity. It is the rate of change of velocity. Like you see, change in speed is considered as velocity. Change in velocity is considered as acceleration. So, the rate of change of velocity can be classified as this difference between initial velocity and final initial velocity by time. The SI unit of velocity is meters per second square. Another important topic is the distance time graph. Motion can be represented on a distance time graph. And this graph, it as normal graph has an x-axis and a y-axis, distance time graph also is considered in the same category. And it is usually a straight line for uniform speed. That is, if it is moving at fixed distance and fixed intervals of time. Let's see how the graph looks like. This is an example of a distance time graph where you have distance on the y-axis and time on the x-axis. And since the object is moving equal distance in equal intervals of time, it is an example of a uniform motion distance time graph. I hope this lesson was interesting and informative to you. So I hope you take care of yourself until we meet next time. Goodbye.